So for today, there's a lot of little pieces of a really hard word problem test that you're going to have next week. I'm going to teach you a lot of stuff. You really got to put on your adult pants here so you can handle one of your hardest lessons of the year. Not impossible, but got a lot of little pieces you have to know. Kenneth, could you shut that door back there so we can cut out some of that hallway noise? All right. This system of equations is almost impossible, but really this is like x, and this is like x, and this is like x, and x, and x, and they're asking to solve for x, and this is like a y, and a y, and a y, and a y, and they want you to solve for y. So it's like systems of equations. I'm just going to remind you what that's like. Would you please write this? 2x plus 3y equals 12. And 3x plus y is 11. If I ask you to solve that system of equations, that's got to be like, oh yeah, I know what to do. But it might not be that way right now. So I'm going to remind you. You have two choices. You can either solve them both for y, which is kind of a pain. It's got like 5 steps each. Maybe not 5, but multiple steps. Or you can remember this way of doing it. You draw the line across, and you add straight down, but wait. You look ahead of time and you go, nothing's going to cancel. This is called the elimination method. You want something to cancel when you add straight down. So do you get if I multiplied by -3 right here, then something would cancel when I added straight down? So can I just go around multiplying one part by -3? No, but I could multiply all the parts by -3. This is called elimination. Do you remember doing this when you were in algebra 2 years ago? Maybe not, but you got to know it today. By now you should have this copied down. And we multiplied the bottom equation by -3 on all 3 parts. Now, sometimes people don't get that. They're like, don't you just have to multiply it on both sides? Yeah, but the one side distributes. Like on this side over here, you'd multiply by -3 on that side, and then it would distribute to both parts. And to make sure you really get that, if I said 1 plus 4 equals 5, you'd all agree with that. If I times this by 3, 1 plus 4 doesn't equal 15, right? You can't just multiply this by 3. It still won't make 15, but if you multiply this by 3, then it'll actually add up. 3 plus 12 is 15. Yeah, it works. Got to multiply them all by 3. Okay, so why was I multiplying by -3 again? Yeah, so these guys will eliminate. That's why it's called the elimination method, and the y's are gone, and now you just have x's. Cool. So now, this makes -9. This makes 2. That makes -7x total. This is -33 and 12. Ooh, that's kind of gross. -21. Ooh, that's going to work out nice, isn't it? What's x equal to? 3. Couldn't you then solve for y pretty easy also? If x is 3, you can go back up to this top equation or the bottom one. Actually, either one would be fine. And stick in x is 3 right here. And all of a sudden you got 6 plus 3y equals 12. 6 plus 3y equals 12. I can do that in my head. Y would just have to be 2. Or you could solve it the normal way. Subtract 6 from both sides, divide by 3. You'll get y is 2. So x is 3 and y is 2. That's the point 3 comma 2. That's where they would cross if they were on a graph. And you might be saying, well, I'm just going to graph them all, because you have to graph on this anyways, and I'm going to see where they cross. And that works sometimes. Because sometimes when you graph things, they meet at a nice clean spot, like let's say that was 1 comma 4, over 1 and up 4. But sometimes they don't meet at a nice clean spot like 1 comma 4. Sometimes the answer is like 1.25 and 4.75, and good luck figuring out what that is from the graph. So this is one of the reasons that this unit that you're going to test on next week is hard, is because you have to solve complicated systems of equations. All right, I'm going to give you another one. Let's say I give you this system. Y equals negative 1/2 x plus 5. Sorry, 6. And y equals positive 1/2 x plus 4. Nice part, they're both solved for y, but you can still do the same thing. Solve the system. Do it. You've got to be good at solving systems for this test. You'll figure out that they crossed at something, comma something. Shabluski, does anything cancel out when you add them straight down?
Yeah.
Yeah, these two do. What do you do with the y's, though? Do they cancel too?
No, you wouldn't.
Like that, right? Maybe that's not what you did. That's what I did. I'm just adding them straight down, and I got y plus y is 2y. And 6 plus 4 is 10. And so therefore y equals 5. Maybe there's another way to do that, but I got 5. Anybody else get 5? All right. So is that the whole answer for everything? No, that's the part of the answer. Now I go stick in y as 5, and then it's kind of a pain, but I get to pick either one. I'm picking the one that's all positive numbers. I'm picking this one. You get to decide. 5 equals 1/2 x plus 4. 5 equals 1/2 x plus 4. I'm going to subtract 4 from both sides. And I get 1 equals 1/2 x. And I'm going to times both sides by 2 to get rid of that. Divide by 2 right there. So timesing by 2, timesing by 2. 2 equals x. Oh, look at that. X is 2, y is 5. 2 comma 5. Raise your hand if you had 2 comma 5. Okay, awesome. Task number 1, solving systems. The first thing I taught you yesterday was graphing systems. Let's see if you can still do that. Everybody go to page, for me anyway, it's page 3. These are systems that have been graphed. I want you to look at them and see if you understand where their y-intercepts are and what their slopes are, and does it make sense to you? Check them out in terms of y-intercept and slope. I think you'll find that they're all graphed properly. Now, if I were to shade inside here, that becomes the what? I told you yesterday, who's got a good short-term memory? Yes. Feasible area or region. Yes. That's the feasible. That means that things inside there would solve all of the problems if I shade the right way. Technically, these are all equals. On your test, they won't be. They'll be like shade under this one, shade over this one. But when we're all done, you'll have corners. And I'd like you to notice that 2 of the corners are nice and 1 is nasty. You get that's an easy one. It's 2 comma 3. That's an easy one. It's 4 comma 0. That one's kind of gross. So do you get, I'm not going to make you do it right now, but do you get that the green one has an equation and the blue one has an equation? And if you wrote them right above each other, like I'm going to go write the blue one right underneath here, y equals negative 1/2 x plus 4. I could do that eliminate thing to solve it and figure out where they crossed. What's the secret on this one? Well, the x's aren't going to cancel nice. Even if I multiply by something on the bottom, unless I multiply by something really complicated, I can't get the x's to cancel. But I could get the y's to cancel super easy. I'm going to multiply everything by a -1. And that makes this negative, this goes to positive, and then this one goes to negative. And then boom, the y's cancel, leaving 0 behind. Don't forget, y minus y is 0. 0 equals, and then this is 0.75 in decimal world, this is 0.5 in decimal world, together 1.25x, and those together make minus 7. And I know it's kind of gross, but you could solve that, couldn't you? Add 7, divide by 1.25, and you get the answer, and it's like a nasty little decimal. That's what your test is like. That's one of the reasons it's hard, is solving algebra. How about graphing? We were talking about graphing. I'd like to go to page 6. Looks like this. In 1 minute, I want you to graph all of these. I will help with y is greater than 1, just because I think sometimes people get confused on which way the y is. This is y is greater than 1. Now that you know that, it'll be easy to do y is less than 3, if that's y is greater than 1. Or equal to, sorry, because that's why it's solid. All right, take 1 minute, graph the others. Use y slopes and y-intercepts. If you stay with me, you're going to get a ton out of today. If you drift, you'll get so lost so fast for one of your hardest tests of the year. I don't feel like that probability test was that hard. There's always a couple kids that like, oh, I just don't get probability. But for most of you, that was a really strong test. Almost everybody. The average was like a 91 or 2%, which is pretty solid. Okay. I'm going to now graph the rest of them in the time you have left. That one's not fun. Oop, I'm not going to subtract 2. I'm going to subtract x from both sides because I want it to be y equals 2y is less than or equal to negative x plus 12. Dividing everything by 2, y is less than or equal to negative 1/2. That's what happens when you divide by 2. Plus 12 divided by 2 is 6. So go up to 6. I'll make this line green maybe. I go down 1 over 2, down 1 over 2, down 1 over 2. Every now and then kind of come up for air and figure out, was it like going in a straight line? Yeah, it's a straight line. Okay, should be a little lower than that. Okay. And now, if I shade under that, your final darkened in shape. So that's what I taught you yesterday, is can you do that kind of thing? John, you can stay with me here. I'm going to have to go take a break. All right, so then the corners become really important. I just showed you how you could solve a system of equations, but on all of these, they're easy to see. Like this one is 1, 3. Right there, that guy right there. 1, 3. That's a corner too. I missed it in first hour. That's 0, 1. I'll make it bright green dot right there. Bright green dot right there. That one, it's also on what's called a lattice point, so I can identify it without it having to go solve a system. 1, 2, 3, 4, 5, 6, 7, 3. And the last one is 8, 9, 10, comma 1 right there. Okay, so two really hard skills. One, this, graphing equations. Two, solving systems of equations to get the corners, but we've got the corners on this one. All right, third hard thing. What if I told you that X axis here was about cookies and the Y axis was about muffins? Now, how would you pick between 0, 1, 1, 3, 7, 3, or 10, 1? How do you pick? Well, I haven't told you enough info yet. What if this is a bake sale? And because the person who brought the muffins at the bake sale is like famous for their muffins, and they're huge and they're kind of expensive, but they make a lot of profit. Let's say we get $3 profit on each muffin. On cookies, the person who brought the cookies wasn't so good at the cookies, so you're only going to get 25 cents a profit on each cookie. They may be cheaper, but you only get 25 cents a profit. Get $3 a profit on the muffins. Now, what you figure out is what's the ultimate combination? What makes you the most money? Think about it. Is it likely to be 0, 1? You're only selling one Y, which is muffin. Not likely to be that. It's not even that likely to be 1, 3. These are all very close to 0, 0, so they don't have many total. But 7, 3 is in the running, and 10, 1 is definitely in the running also. Those would be the ones where they're probably going to make the most money. So this next part is called optimizing. If you optimize something, you are trying to figure out what's the best combination. All right? Don't worry, don't be alarmed. They're just here to... One of them's here to observe me, and the other one's here to observe the other one. It's true. All right. So anyway, I'm going to take my points and I'm going to list them in a table. Everybody do that with me. Ready? 0, 1, 1, 3. Let's do them in the same order as each other. 7, 3. And 10, 1. Now we've got to figure out which one is going to make us the most money. Previously told you that cookies make you 25 cents. Previously told you that cookies are the X. Because see, that's where the X-axis is, right? So would you agree that I get 0.25 for each X plus, what do you think I'm going to write next? 3 for each what? Y. There you go. What I just wrote is called an optimization equation. Sounds really scary. All it is I'm figuring out how much I get for each X, how much I get for each Y. And now I'm going to figure out, if we do this combo right here, 0, 1, it's one of them that's in the feasible region, and I already told you the corners, the vertices, are where you're going to get your answers. 0, 1 would get me 0 for the 0.25s times 0 plus 3 times the Y, which is 1. That adds up to 3. Do you think that's going to be our max profit? Probably not. So then 1, 3. That gets me 0.25 times 1. plus 3 times 3. 25 cents times 1 is 25 cents, plus 9 is 9.25. Now we're making a little more money on our bake sale. 7 comma 3 though, our theory was that 7 comma 3 or 10 comma 1 is probably going to be the one that makes the most money. 7 comma 3 is 0.25 for each x, which there are 7 of them, plus 3 for each y, and there's 3 of them. So 7 quarters is $1.75 plus 9. 9 plus $1.75 is $10.75. You could use a calculator, of course. This test allows calcs. And last but not least, 10 times the 25 cents. I should probably write it the other way around. 0.25 times 10. Plus 3 for each y. 3 times 1. $2.50 of the quarters, plus another 3. Anybody verify 550? Cool. That was all the hard work. Now it's like the easy part. Which one made you the most money? Well, duh. But sometimes the problem isn't about making the most money. Sometimes it's about spending the least money. Let me give you an example. If you and some other company can both make robots, you both make a high quality robot, but you can do it for only $2 million for this set of robots, and the other company is going to make them for $250 million, well, you're going to win because you can make them for only $2 million. That's what I think is actually going to happen with robots. You guys have all seen cool robots before. There's one company out there called Boston Dynamics that made a really cool robot. It's called, do anybody know what his name was? Atlas. His name was Atlas. And he could do backflips and all kinds of really cool stuff, but he cost $250,000 each. If you wanted to buy an Atlas, it's $250,000. Tesla is making some robots, and they've publicly stated that after a few years, theirs will only cost $20,000 to make once they, quote, ramp up. Do you get that even if this is a cooler robot, you're going to sell a lot more at $20,000? Okay, so cost matters. They can make them way cheaper. So they're going to sell a lot because their costs are minimized. So my point is, on some of your problems, you're trying to maximize how much money you make, and on some problems, you're trying to minimize how much you spend. And if you can build the same thing as the other guy can and way cheaper, then you'll win. So sometimes you want the smaller number if it's minimizing costs. Okay, let's go on to this page right here. I've already done one like that, so that's enough of that. Oh, last hard thing you have to be able to do. I warned you. This is tough stuff. This is the 4th or 5th skill that I've gone over today, and that is, can you write the equation? Can you just take a word problem and can you write something like 2x plus 3y equals 24 or whatever from it? You got to figure out the equations. All right. In this case, it's nice because they tell you x is bagels and y is muffins. There's no like trying to decide which one should I make, x or y. But for the future, I've noticed that on these problems, they don't tell you which one's x and which one's y. So whichever they mention first, bagels, we make that x. And whatever the second thing is they mention, muffins, that's going to be y. All right, so for future reference, whatever they mention first, that's the x. Okay, but in this case, they told us. And how do you get these? Let me just show you that it's almost always something in front of the x and something in front of the y, and you add it all up and you get a total. Let's look at this one. He can spend at most $28. That sounds like a total. It's It's going to be 28. A package of bagels costs $2.50. Ooh, that feels like the number that should go in front of the bagels. So instead of 2 here, it's actually 2.5. And in front of the Y, it's the muffins, and they cost $3.50, so this must be 3.5. There you go. That's the last of the skills that you have to know to be able to do these problems. Got to be able to write equations like this, graph them like this, figure out what the corners are from solving systems of equations that we started the hour with, and then once you've got all the corners, you got to stick them in and optimize something. All right. He needs to buy at least 2 packages of bagels. Could you start writing an equation for that? Hint, put it right here. Buy at least 2 packages of bagels. It's not that hard. 2x. And 3 packages of muffins. 3y. Does it tell us how many total packages that we're going to have?
5.
Where's the 5?
No.
I don't think it tells us. I didn't even do this part of the problem last hour, so I'm not sure exactly why we don't have a total here. Usually they'll say, by the way, you need to have at least 7 packages, and then you'd say like equals 7. So we're not going to go on with this problem. It's okay. You'll have 2 equations, at least, sometimes 3. Vertices, you're going to actually like go, oh, here's a corner, here's a corner, here's a corner, and you're going to list them. And then you got to figure out how to optimize the profit. This problem was not meant that you could do all of that because it didn't give you enough info. All right, and now I want to get to the homework because once we start the homework, you'll see these aren't, I don't know. They're not that hard. All right, I know you can't see the homework. I'm going to pause for a second. I'm going to open it now. So here we go. By now you have opened up the homework and it looks like this. You're going to do problems 1 and 2 and 4. So cross off number 3. I will get you started on number 1. Let's all agree that X will be, see, you'll figure out after a while that it's about cars and buses. At first it seems like it's about parking lots, but it's really, the parking lot is where you put the cars and buses. So car is going to be X, bus is going to be Y. X is car, Y is bus. There, I just told you what the variables were, and I told you that system before. Whatever they mentioned first, that's X. Okay, constraints. Remember how I said it's going to be like something X plus something Y equals like a total? All right. Car requires 6 square meters, like how much space a car needs for the parking lot. So then that's 6 for the X. What's the Y going to have in front of it? 30. And what's it equal total? 600. Very good. Okay, that's a constraint. That's one equation. There's another equation, and it's far more subtle. It says the parking lot attendant can only handle 60 vehicles. And it's confusing because they don't even say car or bus. But do you get both cars and buses together are vehicles? Then that's an equation. Can you write it? I'm going to say it one more time. Use X's and Y's. The attendant can only handle, as in the most he could handle is 60. 60 is what? Wait, I guess it equals 60. But what are the things? X plus Y. X is cars, right? Y is buses, right? cars and buses together are the vehicles, and the vehicles have to be less than or equal to 60. Now, it can be less than 60 because the attendant doesn't say he has to have 60, but he could have at most 60. All right. Now, how about this for the parking lot? Can you go bigger than 600? No, the parking lot is 600. That's what it is. You can't be bigger than 600, but could you be using up less than 600? Yeah. So this is actually a less than. So that means when you graph this thing, you'll shade underneath it. Now, oh, cool. It's already graphed. Yay. So they were trying to make this a little less suffering. Last thing, optimization equation. It must be that they have some more info. Look at that, they do. It's right here. Can you make one of those little equations? Like you get $4 for this and $2 for that. You have to be able to handle at least that much. Make the optimization equation. And if you want to say cost equals, you could do that, or profit equals, or money equals, or all right. I'll get you started on number 2. Look, it's already graphed. That's the good news. And I can see the corners. They like told me what they were. Look at that. No issue of like doing complicated solving systems of equations. I got the corners. Remember, the shaded region goes forever. It's kind of like there's not constrained. You could keep making more and more and more, but you're trying to have minimized this one. You want the smallest total cost. It's kind of like the robot question I was asking you. Like if you were going to make 1 million robots here or 1 million robots there, and one of them was going to cost way less, you'd do that. Okay. So what do I have to write here? Variables. Ooh, that's x equals and y equals. Just figure out what they are. Maybe it's like muffins and cookies. Constraint, you'll always have some equation that's like x plus y equals. Maybe it's something in front of the x. And last thing is, what is the minimum cost? They want the least amount. So we're going to set up an equation for our costs, and here's where it says the costs. 30 per hour to make dump trucks, 30 for each, and I think dump trucks was X. So 30 for each X plus. All right, I've gotten you started. Don't forget at the end here, you're going to have to pick between 0, 200. See how much money that makes you, or costs you. 88, 24. See how much money that costs you. And 160, 0. And you see how much that costs you. And you want to minimize costs. All right, I'm giving you the setup for number 2. It's not done, but you got to do something. And then number 4, I want you to just do it yourself. Now, this is one of those moments where I could totally see myself forgetting to post the key, because I don't want to post it yet, but I want to post it later so that when you're at home over the weekend, you aren't totally lost. But I don't want you to just go look right now, copy in the answers. So if anybody notices that it's after school and you've gone to do your homework and it's not there yet, send me a 2-second Schoology message. I promise to stop whatever I'm doing, run back in the house, post the key. Okay? I'll try to remember. I do respond to Schoology messages really quick. All right, that's all I got for you for today.